Good morning, everyone. I am Sukanya from BSc Chemistry on our final year. I am making a inorganic chemistry video for visual impaired student. Uses of organic and inorganic reagent in inorganic analysis. Introduction. Reagent are those compounds which are used in inorganic analysis for the detection and determination of ion and molecules. A large number of organic as well as inorganic reagents have been used for this purpose. The inorganic precipitating reagent generally precipitate the inorganic species as sprinkle soluble salt or hydrous oxide. The organic precipitating agent forms sprinkle soluble product either through coordinate linkage or through ionic linkage between the inorganic species and the organic precipitating reagent. Advantage of using organic reagent. The advantages of using organic reagent are listed below. They are more specific than conventional reagent under certain conditions. Because of this property, they can frequently be used to detect a single type of ion in a complex mixture. They can be more sensitive. Classical semi micro method of quantitative analysis will usually not detect much less than 100 gram of a substance under specific test solution. Organic reagents, on the other hand, are capable of detecting below 10 lambda and in certain cases as little as 10 13. They can be adopted in quantitative analysis. The organic precipitate are generally insoluble in water at a given pH and can be separated dry and wetted. Those reactions giving colored soluble product frequently show a regular change in color intensive with concentration of a substance under test and so are adaptable to an accurate comparison with color representing concentration. This is the basic idea in a branch of colorimeter. Common properties of organic reagent. Some of the common properties of organic reagent due to which these are used in inorganic analysis are given below. Formation of colored precipitate. Organic reagent form direct characteristic color with the ion to be detected. For locating endpoint, that is as indicator employed in volumetric titration. Formation of precipitate due to difference in solubility. This may be made on a basis of galvanic method. Extraction in organic solvent at control pH. Mixing reagent, this increasing the selectivity of reagent. Difference in volatility, oxidation and reduction to other valence state. Vast liquid. The chemical nature of the organic reagent is important in determining the use of above mentioned property. Advantage of organic reagent over inorganic reagent. It is due to flowing property that they are better precipitating reagent than inorganic reagent. Selectivity. In many cases, organic reagents are somewhat specific. For example, cobalt from nickel using alpha nitroso beta naphthalate or dimethyl glycoside. Aluminium from iron using Caphron, cadmium from copper using quinyldic acid and thiourea can be precipitated. In some cases, adjustment of a pH will often cause precipitation of one constituent alone. By changing pH and solvent condition, one constituent after another can sometime by quickly precipitate out. Ease of drying. Organic reagent produce compounds that have little affinity for water and are dry easily at temperature low enough to prevent decomposition. Co-precipitation, lack of ionic character of organic precipitation product greatly reduce co-precipitation. In most cases, for example, the co-precipitation of sodium and potassium with magnesium is much less when the latter is precipitated by 8 hydroxyquinoline than when it is precipitated by phosphate or oxalate. Some exception in metal do occur. It has been little studied, but in some case it is as bad as in inorganic precipitate. Reagents are usually insoluble in water. Therefore, it is important not to add an excess of reagent. This is difficult because there is no way to tell when sufficient reagent without excess has been added. Any excess that is insoluble would add to be weight of a precipitate. Disadvantage of organic reagent. There are unfortunately disadvantage to using organic reagent. Volatility. This is the first practical disadvantage of organic reagent because chelated compounds are non-polar. The force between individual molecules in a crystal are not very great. The sum of the metallic complex which are precipitated in analytical chemistry are volatile above 130-150 degrees Celsius and most decompose above this temperature. Therefore, the drying of precipitate should be done below 130 degrees Celsius to avoid decomposition. Impurity in reagent. It is very difficult to prepare an organic reagent of the same degree of purity as say inorganic compound. Impurity present in organic reagent may enter into the precipitate during the precipitation and cause undesirable reaction. For example, dimethylglycosamine exists in three forms: alpha, beta, gamma. Of these, only the alpha form is specific for nickel will prepare dimethylglycosamine. Gamma form is also formed along with the alpha form. If the precipitate is carried out with this mixture dimethylglycosamine, then nickel will be precipitated with some other metal because alpha form is specific for nickel where gamma form can precipitate other metal also. Keto-enol isomerism in such compound as dithiazone will cause error in colorimetric work unless conditions are used carefully selected. Low solubility of a reagent in water. This is the greatest disadvantage which organic precipitate have in composition with inorganic precipitant. High molecular weight. The very high molecular weight of chelate complex formed with metal ion reduce proportionally some small error in precipitate and weighting. Colored compound. Chelate compounds are often highly colored and since they are usually soluble in organic solvent, they lead themselves to colorimetric or photometric method of analysis. Solubility in organic solvent. Because of their covalent nature, most metal complex with organic reagent are soluble in non-polar solvent. Chloroform being usually the best. Such solvents are used to extract the complex for colorimetric determination or they may be used simply for separating one element from another. Thus, the complex of cupron with tripositive iron is very soluble in ether and chloroform, which allow one to remove large amount of iron from solution containing aluminium. In this extraction, the pH must be carefully adjusted to give the desired separation.